But before we go down the paths of data in our morning session here, I'm going to tell you a bit about myself and before University of Chicago. And at some point, I hope it all makes sense because it's been a bit of an odd path. Excuse me. I grew up in the Silicon Valley world, so I spent 7 years of my life doing a startup. I don't know why. I think anyone in Scotland would have heard of it. Have people heard of OpenTable? Is that a win? Okay, I feel better already. So, in the late '90s, we came up with this idea that the way that they did reservations in restaurants made no sense. Like, you go to your typical restaurant, and I'll speak for the US, you have an old school maitre d' who has this massive book of reservations and knows people. And that's pretty good. It's a good niche business. But we thought of the idea, well, what if you made this all electronic? And you turned it into a web-based inventory system, and you could create client databases and stuff like that. Now, the idea in 1999 was long before its time, and people thought it was completely ridiculous, but we did it anyhow. And it ended up being a great data play because restaurants would be able to understand their clients, knowing what people want to do and things like that. So over 7 years, we took this from a tiny little, what we would say in the US, a couple dudes in the basement writing software and wearing jeans, definitely not wearing suits, into a multinational company. And now if you go into most major restaurants, you use OpenTable. We went public in 2009 and were acquired by Priceline 2.5 years ago. So I am completely done with OpenTable, but that is where I grew up. I was an applied technologist. I built the architecture, I built data centers, things like that. Now, how does this make any sense? If he knows about computers and dining reservations, why are we in Sterling? So this is where the story gets a little odd. Now, so in our 9/11, I was traveling because at OpenTable we were building out all sorts of markets. I was at the airport when the planes hit the towers. I was evacuated off an airplane, and I spent the majority of my day trying to find my team members because I had people all over the country, everyone traveling, and eventually I accounted for all the parties. But driving home, I had a bit of an epiphany. I said, well, so my focus right now is helping wealthy people make dinner reservations. What am I going to tell my kids, which I had not had yet, about what I've done with my life? He built an enormously successful startup, but that's it. So I vowed at that point to do public service whenever I was done with OpenTable. Now, I had originally thought I was going to be done with OpenTable after a few years. It took 7 years. But after the 7 years, I did probably the craziest thing a computer scientist who knew nothing about anything in the real world could do, and I joined the Chicago Police Department. And when people get a little confused by this sentence, when I say I joined the Chicago Police Department, they think I went in as a computer guy. I went to the police academy, and I did push-ups, which are actually really hard. I'm really not good at anything athletic. I'm really proud of myself if I can walk without tripping. I went to the police academy. I graduated the top of my class, and I chose to work in the most violent district in Chicago, where I spent all of my time in essentially preventing shootings. And I learned a lot about the real world, but where does this get interesting? It gets interesting because, as everyone in this room knows, policing is a bureaucracy. It's a very old school business, like many of the things we see out there, and they do things the way they've always done it. And guess what? Sometimes when you do things the way you've always done it, you need a little change. So a couple years into my time at the police department, I ended up being with the PD for 5 years. They figured out I actually had a couple graduate degrees, one in computer science from University of Chicago, and I got immediately transferred to headquarters. Like overnight, bam, I'm out of the field. I'm no longer chasing people, and I'm at headquarters. Now, we had a new chief of police, and he assigned me to figure out how can we innovate with data. Because in my second stint in graduate school, I had started to think about how could you predict where violence would occur using new types of data. So imagine predictive modeling where, like, I am sure if I went to a local police department, they would say crime begets crime. Well, I can tell you that's not actually true in many cases. So I created a new unit, the first of its kind, which was a data intelligence unit. Our job was to use machine learning and predict where people would get killed. So I spent a number of years of my life producing it's called high resolution targets for where people would be shot, and we would send in interdiction teams to prevent the shooting. And in some cases, I would be on the interdiction team. And the funny thing is, the first summer, like, I don't know if people know about Chicago violence. We have violence. Like, it is one of the more violent cities out there. And the first time we rolled this out as an intelligence product, we had the lowest homicides in 40 years. Because we found that increasing our data literacy, using computer science techniques, and collaborating with on-the-ground units and modernizing how we did business changed outcomes. And that was fascinating because many people feel you can't fix these types of systems. So that was great. That was awesome. So I did 5 years. I was going to go do another startup because I had had a 5-year break and it was back to my jeans and t-shirt. And I didn't want to carry a gun anymore. But there was an interesting event, excuse me, in Chicago where Rahm Emanuel was elected. Now, I talk about Rahm, and I assume everyone in the world knows who that is. And that's a terrible assumption. So Rahm Emanuel was President Obama's original chief of staff. And when he was done doing that, we found out that Mayor Daley, who had been the mayor of Chicago for 21 years, was retiring. Now, Daley did things, same way for a long time. Rahm comes in, Mayor Emanuel comes in, and he says, I'm going to do things differently. I'm going to innovate, I'm going to have a modern government, and I'm going to be very transparent, and I am going to have a data-driven government, and part of that is open data. So I didn't know anything about this, which is fine, because I was retiring from the PD and I was going to go do another startup and go back to my jeans and t-shirt. But I get a phone call on a Sunday night after he's apparently been elected saying, can you come down to transition headquarters? And I'm like, why do you want to talk to me? I'm just like, I know nothing about politics. And the mayor wants to create the first chief data officer position. He wanted someone in his direct reports to run data in Chicago. And he's like, I've heard you've done some super awesome expletive. He swears a lot, but I'm afraid of the recording. And I want you to change how things are in Chicago, and I have your back. And he's like, I don't know a lot about technology, but you're going to help us do this. So I go and I talk to my wife. I'm like, well, what do you think? And she's like, you want to be a political appointee? I'm like, not really. But there aren't a lot of good ways to say no. But part of my challenge, and people find this really surprising, I didn't know what open data was. So he's like, you need to run open data. So I go home and I ask Google, I'm like, what's open data? Because remember, I was a commander in the Bureau of Counterterrorism and Intelligence. We do not, there was not an open data program. I was dealing with everything was closed data. Everything I did was quiet interdiction to prevent people from being killed. So moral of the story is I learned what open data was, which was handy because I read some press releases. And he and I spoke, and I said, well, open data is important, but we need to not just get a press win, we need to have a true data program. He agreed, and he said, you're taking the job, and I said, well, I guess I'm taking the job. And so I became the first chief data officer in Chicago. Now, it's the data program in Chicago started as you see there. Me in an office with nothing on the wall, having to wear a tie, and I really don't like ties, and a couple computers. And where that's an important lesson, and I'd ask people to think about, is I started from nothing, and I had no resources. I had me. Now, one of the things I sometimes get a little impatient with when I talk to folks is they're like, well, I don't have a big staff, and I don't have a lot of money, and I don't know what to do. And my response was, I had no money, I had no staff, I didn't even know what open data was. I had an office, and I had a phone, and computers. And that's where Chicago started, because if you look at any of the history in Chicago, we were not transparent. Like, there was often contention with the press. FOIA could be quite contentious. Things were not released. And so I looked at the program, and I tried to be thoughtful about, so I went in, and I had no desire to just have a position but not effectuate impact. Like, that's not why I would do time in government. So I wanted to immediately have wins. Now, I try and think very strategically about what wins are. One, I want a good long-term vision on where I want things to be, and we'll talk a little bit about that later. But I also want people to not sit waiting for a program to become real. Because when you're one of those people who just talks all the time but doesn't deliver, then it's just blah, 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 blah. Now, an interesting analogy in the software world is back when I started doing software, we used to have something called the waterfall model, right? Do people know waterfall? So it's the software development lifecycle. It's how do you build a software product? And the way you did waterfall is you would have a plan which would say, over the next 2 years, I'm going to build an amazing software suite, and you'd lay out every little step of what it's going to do. Then you'd go hide in your corner and write code for 2 years, and then you'd come back and say, look at what I did. And the problem with waterfall is you'd say, look at what I did, and it was often wrong. Because users won't see it, and my perception of what should be built is often not what the person who needs it should be built. So what we started moving to, I don't know, a decade ago, is something called the agile model, in which you have frequent communication with your constituents. This is what I did. And then your constituent can say, it sucks. And then you say, okay, I'm going to fix it. And let's talk again tomorrow. It's called minimum viable products. It's called fast iterative improvement. And that is something I'd adhered to, and I took it out of software, and I said, how do we apply this to government? How do we have wins? So I took a really bold move. So I started in, I think it was May 11th of 2011, and I said, what could I do that would have really big impact? And in Chicago, as you might suspect, crime is a very, very big and interesting piece of data. We have a lot of it. And historically, we have not shared much of that data. So you could get 90 days of the crime data from a website, but you'd have to write a little web scraper and then store it in a structure. We never would release it in a friendly, in a friendly way. So I said, what if we released all of our crime data? Now, that was completely insane, right? Because you're going from a little website with a map that has 90 days of data to releasing a decade plus of incident level crime data, which would equate to 4.7 million rows of data. Big, big, bold move. But I also have an executive who wants to be the best. I want to show we can do it. And I also want to take a risk because from the political side, people think that if you release that kind of data, the world is going to end. Now, the world at some point may end. That's sort of out of my expertise. I do not think it will in fact end due to 4.7 million rows of data. So I decided to do it. Now, this was interesting because our platform was Secreta, which is one of the open data portals. There's Secreta, there's CCAN, whatever you want. And I was pretty convinced I was going to break Secreta because that was the biggest data set they had ever seen. 2, I thought the police department was going to kill me. Now, awkward because I was former police. So the day before, right before we're ramping this up, I go ahead and I call the CEO of Secreta and I'm like, I'm going to break you tomorrow. And he's like, not good. I'm like, I'm calling you at 4 a.m. tomorrow, and we're going to check in and do that. And then I started hiding from the police department. So I stopped answering my phone. And because the chief of police was calling and being like, we need to talk about this, I'm like, send a voicemail. And so what we did is we released it. And overnight, Chicago went from being a backwards player in the open data space to like the Associated Press took the story and it became a worldwide story about a new Chicago and releasing data. I crashed Secreta, so which like once the AP took the story, bam, they went down. The chief of police stopped calling me. And I started getting calls from New Zealand and Australia and places saying, can we do live air? And I'm like, I don't really like press. But the funny thing about it was everyone was terrified, but everything was okay. And the mayor got a win. The police were fine. Secreta crashed. But they came back stronger. And we in Chicago showed that we could do this. It cost nothing, and we were on the open data stage. Now, when you look at where we started, like this is a pretty, I apologize for the resolution, a pretty measly original portal, right? Little data, not very interesting, but it morphed into a robust, one of the biggest platforms that's out there. Now, some things that are really important about open data, which everyone here already knows, but I have the floor, so I might as well belabor, is how you architect it is very important. Now, I get very nervous about data portals in which are what I would call are one-hit wonders. You have a data set, someone sends you a spreadsheet, and you just post it, okay? What I believe in are ones that are architected from an engineering perspective. Because a word that is not often mentioned, but is critically important, is sustainability. Now, if it requires me as the data coordinator to get onto a portal, upload a data set, is that really open data? I guess definitionally, yes, but it's not sustainable. The way I architected it in Chicago is little blocks of software that update all of these data sets automatically. So you have underlying transactional systems, and we're going technical for a second. You have in, say, Chicago, you have about 1,100 databases, right, that are the core transactional systems for how the city runs. you have little blocks of software called ETLs, extract, transform, load software jobs, that then feed the SOTA API behind the Socrata interface. Now, why is that important? Well, how are you guys going to turn it off? So if you have little blocks of software that are running on servers and most people don't really know where they are, it's pretty hard to shut down an open data program. If it requires Brett to go in with supervisor approval to upload a spreadsheet, that's a little different. Sustainability is key. Architecting these things to be automatic is key. Now, something that people were always very surprised about in Chicago is there was never anyone who looked at the data in between the transactional system and the open data portal. Like I joked, I'm like, there's no little dude in the basement of City Hall checking line by line. Is that the dangerous piece of data? Because, you know, maybe data a few years ago, you could do that, you could spot check things. We now live in a world within these administrative systems where you have hundreds of millions, if not billions, of pieces of data. You can't do that, and you'll break the system. So that sort of sustainability is key. It also builds trust, because part of a good open data program is one in which people trust it. If you say, I am checking the data to validate it before it goes out the door, how do you build trust there? If you say it is automatically out there, that's pretty interesting. Now, one of the things that they expected in Chicago was that it was going to be contention between me and the press. I'd put things out. Now, if you put out 100 million rows of data, I can promise you there are errors in there. There's just no way you're going to escape that. And people thought that the press would jump on me once they found an error. And I found it was completely the opposite. I had an open dialogue with the newspapers, and I'm like, look, I'm putting stuff out there, and if I make a mistake, you call me first, because we're working together here. Because if you burn me, it's only going to hurt you, and then we both lose. And it worked, and they went for that. And I sometimes say that line, and people are like, well, not my press. And I'd say, look at the Chicago press. Like, there are few more contentious relationships than there are in Chicago. So you can make these things work. And today, Chicago is one of the biggest data programs in the world. It is automated, it's robust. You know, I hired my successor. We have a chief data officer there. And it's shown that it can work. And where it works even better is, you know, it's not good enough to just have an open data portal. I measure success on what rides on top of it. So if you have APIs in your data portal, then there should be applications running on top calling that data. And you can measure that. If people don't use it, that would be too bad. But there are applications all over the place now that rely on this API. So this drives a variety of things. What does it drive? It drives research. It drives consumer apps. You know, applications I would never build. I'd never use government funds for like, show me where the snowplow is, or has my car been towed, or, you know, which is actually super handy. You go like, hey, I can't find my car. I enter in the license plate. Oh, it got towed. Two things that are actually more interesting. You have companies like Nielsen who take our data and are able to create economic value. Like open data can be an economic enabler. It is not just a hippie activity. It is something that gets at research, academia, consumer apps, civic apps, but also economic development. It is something that will be an economic multiplier. Now, I promised that as we sort of worked our way through this, I'd give you a broader vision for data, because I view open data as a piece of the puzzle. I don't view it as the whole picture. I would encourage countries and cities and jurisdictions to have a broader data vision. And how do we make people smarter through data? How do we promote data literacy? How do we simply put, do business smarter? So one of the things, and this is a bit of a fun story, we'll talk about the Windy Grid project. And if you're up late tonight and you're really bored, you can Google Windy Grid, and I know that's what people do at night. So I get into the mayor's office in 2011, and we have in 2012 coming up the big NATO summit coming to Chicago. Now, Chicago does not have a history of doing really well with very big events. Like in 1968, we had a bit of a convention challenge, which will go down in history for a really long time. And so now we have NATO, and we have all the protesters promising they were going to come visit us. And how are we going to manage this? So if we put on my public safety hat again, there's a concept called situational awareness, right? In situational awareness, you want to say, if I am operating in a given geographic area, how do I know everything that's going on, right? Like, where are my police cars? Where are my 911 calls coming from? Where are my garbage trucks? Where are my, where are protesters? And so you say, okay, that should be pretty easy. But nothing about that's easy, because we didn't build technology that way, because why would we be smart? And instead, you have all of these transactional data systems that are disparate and siloed. A classic case when you're talking about data analytics, siloed data. And you may have one system which says, here are my cop cars. I can promise you that's a different system than where are my 911 calls coming from. And so the chief of staff to the mayor comes to me and is like, so we need situational awareness. And I'm like, yeah, you probably do. And the typical way that you would get at a problem like this is have a big procurement. You'd have an RFP, you'd get like 20 million US, you'd get one of the big folks like Oracle and IBM to build you a system, and it would take 2 years and be over budget and past due, and we had less than a year. And as far as I could tell, I didn't have anywhere near $20 million extra for the NATO event. And so the chief of staff says, well, you can just solve it. And I said, okay. So this is where it became interesting, because remember, at this point, I was the chief data officer. I was very intimately familiar with all of the data we had, but I didn't know how to tie it together. And this is when I decided I was going to introduce open source into the Chicago technological ecosystem. So there's a product out there called MongoDB. It's a NoSQL big data architecture. And the whole idea was, I am going to take an open source technology, which was at no cost, and I'm going to bring together all of my siloed data together, and we're going to be able to know everything that's happening in a given place. And we're going to do it on our own. Now, I could spend the next hour talking about the technical architecture to Windy Grid, might not be a good use of time, but the lessons here are pretty important. One, we had enormous data assets. Two, we said we were going to introduce open source into our environment. Three, we were going to say we're going to do it on our own. And we're not going to say it's too hard. We're not going to say it's too complicated. And so originally it was a stack of computers in the mayor's office suite, which he found remarkably amusing. And we sucked in all of this data, and we solved a few key problems. One, we knew, and I apologize, I usually include a screenshot of Windy Grid. Imagine a big map with situational awareness. Here's what's happening in a given place. Two was this ability to create a deep dive. Now, often you say, I am looking at a area. So in this, we're in the courtroom. Tell me the entire spatial history of this. you have the data, but how do you actually access it? We now took all of that data, put it into one place, had billions and billions of rows of data, and could say, tell me everything we know about this. Imagine as a city, as a government, having the total picture of all of your spatial data temporally. You start to be able to solve many, many interesting problems. And the third piece was, by architecting it that way, we started to say you can use real analytic tools on city data. Now, there's a program called R. Has anyone heard of R? All right, you win, and you win. So you can take programs like R, which is a very, very robust stats package with machine learning add-ins, and you can say, call MongoDB and start to do really smart things. And again, what was the cost? 0. Now, there used to be a statement in Chicago, we can't afford to do advanced analytics, right? Because the really friendly tool, and it's a good tool, I could teach my 9-year-old how to use it, IBM Modeler. Great tool, it has little things, you drag it and it just does magical things, but it was $14,000 US a seat. Too expensive. R, free. And wow, you can do advanced things. And so one, we survived NATO, but as a side benefit, we created an architecture where we could take all of those data assets that we had been talking about and integrating and making open and start to do some really, really smart analytics. Because if you think of your data-driven trajectory for your government, for your city, for your country, you want to think beyond just open data. You want to think about how do you get toward, like a phrase I'm sure people hear all the time is smarter city, smarter government, smarter whatever. Again, if I weren't being recorded, I'd probably have more colorful words for my thoughts on some of these smarter programs, because often it's complete nonsense. It lacks substance, or it's one-hit wonders. Smarter cities are about sustainable architecture, sustainable foundations in which you get meaningful insights that you can replicate and then expand on. And that's something that requires real architecture underneath. Now, one of the things that I started to realize, and I'm sure people here are being very thoughtful about this, is we started to need a new type of person to be able to traverse these new worlds. Now, in government, you tend to have IT folks, right? And IT folks, you have your email administrator and your database administrator and your help desk dude. And then you have policy folks. And policy folks are really good about talking about big ideas. And look, my fellowship's in a policy school, so I see plenty of this. Or doing longitudinal studies, which can be really great. And it's really awesome to be published, especially if you're on the tenure track. But if you're in government, you don't have 2 years to do a study. You don't have 2 years to do a white paper. You are surrounded by data and you need insights today. If you're going to make a data-driven decision, you need to be able to crunch it now. And I realized we needed to start to bridge this gap between policy and technology, and we needed to start to create folks who are data literate and who are able to say that I'd say, here's a problem, I need you to solve it now, and they can solve it in a way which was safe and interesting and good math. And early on, this was really hard. Like, I had a bunch of 24-year-old kids who, I guess they were smart, but they'd sit down and they'd, you'd give them a spreadsheet, they'd try and do a regression, they don't know what they're doing, and they give you a number and the number's wrong. And all of these things. But then, then I realized that we just had to start training people. And we did this in 2 ways. One was on-the-job training, where I would take policy kids, and then we'd take their classical statistics training, because like at programs like U of C, you have decent, rigorous quant programs, and you do 2 tracks. One is teach them non-traditional techniques that come out of CS. there's an enormous difference between your classical statistical toolkit where you're dealing with the regression family and being able to think about a neural network. And great, it sounds different and it is different, but you need more tools. And why do you need more tools? Because government and administrative data is not always clean. And when you have dirty data, and I got this discussion, I get this discussion all the time. Like I'll get into it where the people will say, well, the data's dirty, so you can't use it. And then I'll say, well, we should just probably shut down government and let's not do that data thing anymore. But instead, and I wrote a chapter about this in an O'Reilly book where the chapter I was being funny. I said, don't let the perfect be the enemy of the good. I completely stole it. And talking about how you should use dirty data. You just need to think about techniques. So we started teaching the policy kids new techniques, and then we started to teach technical people how to talk. And I can say that because I'm a computer scientist. Getting up in front of an executive was never really my strong point because I can be overly precise, I can be overly detailed, and he'd be like, shut up, just give me the abstract. And we found that by getting people to bridge these worlds, they were able to navigate and solve real problems. At the same time, actually a year or so later, at University of Chicago, we started a new program. And it's a dual degree program, which was the first of its kind, where you get a graduate degree in public policy and computer science. And that's fascinating because we now have kids who go into all levels of government and they're able to traverse these worlds. They're doing neural networks and they're briefing, senior executives. And when I say to them, I need you to write a call to MongoDB and be able to give me an answer in the next 2 hours, they do it. But when we think about the next generation of who's going to work in government, that is who we need. Because they can speak data, they can execute, but they can do a good briefing. And when I say speak data, I probably should have said speak data safely. Because data can be very dangerous. We all know that you could give someone like me or others in the room a pile of data, and I'll tell you whatever story you want. That's risky. How do we tell the right story? And how do we tell the honest story? So when I think about the foundations for open data, you think about bringing, and we've talked about many of these pieces, integration, standardization, and then automation. Like automation is key. I would ask you to remember that piece. So let's push ahead. I've been going slower than I should. So there's a ton of data out there, right? So you have so many different pieces. You have city service data, 911, 311, things like that. Incident level data, easy way to think about that is crime data. And then you're starting to have bigger data. Now, I'm always hesitant to use the phrase big data. It's completely overused. Every vendor will talk about it. Everything's big data. Most of it is not. But there's hype. I think the hype's fading a bit. Have people heard of the array of things out of curiosity? No. So it is a fixed place sensor system that came out of Argonne National Lab and University of Chicago. I'll talk about that in a bit, but imagine big IoT data. So data comes in many shapes and forms, and everyone knows this. So you have structured data, your typical what you'd expect in Excel, aggregated, that's often calculated data, sensor data, we talked about IoT, and unstructured, like the Twitters. So if anyone is twittering out right now, that is unstructured data, which is begging to be structured, and it's kind of a solved problem. So you look at things like crime, this is structured and pretty straightforward. Then it becomes point level data. Shootings, unfortunately too many shootings, but this is a very popular data type in which it is spatially enabled and temporally enabled. You see this in many, many types of government data, often referred to as GIS style data. So in theory, as you have bigger, better urban data, you start to get that better policy decision. You should, because you have the data, but remember some of my diagrams before in commentary, we need to train people to be able to work through, because you could easily see how that is changed. So then we think it and we say, you note my little flippant question mark. Is it a better policy decision? So some of the things that we're thinking about at University of Chicago are systems that can help support this. So we built a project, and this is Argonne University of Chicago Urban CCD project called Planario, which is, remember, and this is open source and public, and it's on GitHub. Remember my desire with Windy Grid to be able to have one massive spatial index. So the idea behind Planario was, could we build excuse me, an architecture which you'd be able to deposit all of your open spatial data into one portal. It will go into a Postgres, PostGIS implementation, and you can call any of it and outsource it. So I found it frustrating, and so we built it. So we have this platform which people are able to contribute to. So say, and I apologize, I don't know all of the governmental units here, but say in our given spatial topology, you can insert any spatially enabled data. Planario will handle the back-end processing of it. And you could say, tell me the story of this building and any of its data. Or let's say you wanted to have your own environment. You can go ahead and clone the repo and create your own Planario and then have your own Scottish story of spatial data. It is something that can take open data to the next level. It also becomes a foundation and highly supportive of advanced analytics. Again, a case where you can use open source technology to be able to support a data-driven mission. And on top of it, we created a user interface. Now, in general, I'm not a big UI guy. Like, I like APIs. I'm more of a bring out the Unix type. Again, doesn't make me popular, but but there's an interface to be able to make it friendly for the variety of constituents you have. It's one of those things where, as you think about your open data and your data policy going forward, you should look at existing tools and say, what can I beg, borrow, steal? And be able to show, one, you can show what can be done, but two, as you build out a program, there are tools that can help you execute on what you want to or what you need to do. So let's make this a little more complicated because we're 48 minutes in. So maps are complicated. So you've heard me a couple times talk about spatial data. Most data falls into a couple distinct categories. You have financial data, which is really important and really critical, and lots of interesting things there. You have individual level data, health data, things there, really, really interesting, really, really critical. But a lot of what is out there is spatial data. And when you talk about spatial data, you're talking often about maps, right? And maps are great. I really, really like maps, especially when I'm in Scotland and I don't know where I am. But maps have issues. Now, since you're all pretty, I think, reasonably knowledgeable about this, how familiar are you with the modifiable aerial unit problem? Is this something that people have pondered? No, okay. All right. So the idea is behind the modifiable aerial unit problem, it just flows off the tongue, is that what is your right unit of analysis? So if you are doing an analysis of a given problem that is based on point level data, you often have to say, at what unit of aggregation do I use? Now, in the States, we often talk about political boundaries. We have cities, counties, districts, precincts, census tracts, census blocks, all of these different pieces. But what do any of those different things mean? Now, let's apply this to my old real life. When I was a commander in the police, so I often spent a lot of time looking at the west side of Chicago. So if you're ever, again, bored after you're done Googling all the other fun things, you can Google crime west side Chicago. Now, if you look at the west side of Chicago, and let's go back to, okay, so this is where I used to work, okay? High concentration area of shootings. This is the other high concentration areas, west side, south side. Now, from a political boundary perspective, there's a line right there. Now, you say there's two police districts. There's district, so this is District 11, that's District 10. Now, the line imposes dilution on your unit of analysis calculation. Now, why is the line there, right? Because it's some political boundary that was calculated for the point of having a district. Now, when you calculate where your boundaries should be, they radically impact your understanding of what happens in the area. This is a significant issue for both political reasons, but also understanding where problems are. So as a data program evolves, you need to say, how do I calculate areas within my given spatial area? And over-reliance on existing political boundaries can be very, very problematic for analytics. So you need to be thoughtful about this. And I know, and I just like, I hear the pain, I'm like, oh, complicated political boundaries, things like this. Exceptionally important. So you start to think about dynamic calculation of areas to understand problems. So we have a program at University of Chicago, and again, because I'm kind of really bad at naming things, I call it the blobs program. And the idea is dynamic creation of units of analysis to better understand multivariate homogeneous problems. Again, a mouthful. But let's think about what I just said. The idea is, and let's drive this to a data-driven program where you say, I have a city or I have an area. I want to understand the subdivisions within my area based on data attributes. And those data attributes change based on the problem sets. So I should, dynamically calculate the areas based on those problems. So this is a fun illustration where you say, so in the blobs method, we use this algorithm called PySal. I'll let you Google it. I won't walk you through the algorithm, which says calculate the area based on the attributes I care about. Based on traditional mapping, this looks like a really happy area, assuming green is good, red is bad. Yet when you dynamically re-understand your units, you start to see that this area behaves differently than this area. You need to be very, very cautious about making sure that you understand how areas behave differently. The beauty of data allows you to garner these little microgeographies that behave in different ways. So my wife, who is way smarter than I am, spent a good chunk of her career working, she's a public health scientist. Her focus was on oncology. And back in, we've been together 21 years. So early on when they would do cancer treatment, they would treat the whole body, right? Which was really hard on the patient, right? So now they do hyperlocal treatments. You only treat the problem area. So take that idea, because often in computer science and data science, we'll steal ideas from medicine, because why wouldn't we? And you say, how do I identify my pinpoint area to treat? You will have the data to do this. It is important as you build programs to put in the techniques to make sure you understand what you are seeing and be able to have the right treatment in the right place. It is complicated. And sort of technically, and this is completely technical here, but there's a whole sort of area of thinking as you advance a program and tools that you can leverage and not rebuild to be able to get into this space. So the last sort of bigger project that I'd sort of give you some vision around is this array of things. So as I mentioned before, there is enormous amounts of sensing that are occurring in the world. Like everyone talks about sensors and big data and machine learning and AI and all of that. We all have sensors here. Like everyone here seems to have a phone, right? And you're all releasing lots of digital exhaust. And usually there's one person with two phones. I haven't seen that person yet. Oh, there you go, win. See, there's always that person. And you all use the Twitters and Facebook, and you've given everything away, and there's tons of information, and that's really mobile sensing. But there's this area now of fixed place sensing. So we've created these units, and I advise this project, which are put on light poles. And imagine it as, I always struggle for an analogy. A honeycomb, apartment building, it's real estate on a pole, and you put in things like air quality sensors and things like that, and start to get micro level data about what is happening in that area. Like how much sun does it get here? What is the particulate composition? We have a downward facing camera. Get at sort of, what does traffic look like? We have an upward facing camera. You actually see some really interesting things going by once you figure out how to classify it. And we're putting these out there because remember when we were talking about the modifiable aerial unit problem, understanding behavior at a hyperlocal level. Now, what makes this interesting and how does this all tie together? Couple things. One, we're looking at informing cities with very, very high resolution data, how to inform what's going on there. Like, what are the problems you can solve? Well, if you're looking at street segment X, why is the air not of the same quality as street segment Y? Maybe we should figure that out. Or B, why does everyone walk on that side of the street? Is there a reason? Or in egress from the train, like it is always well, at least for me, it's terrible when you get off the train and you're in that really high density, slow moving cohort down the street, and it's just, why is it taking so long? How do you potentially redistribute the population there? How do you take that? Now, what's fun about the Array of Things project is we're making the data open. Now, this is interesting because it's trying to solve a couple problems. One is sensors can be scary. Now, the more you understand what a sensor does for many people, it can make you feel sad. It can make you feel mad. It can, it can make you crave a glass of red wine and say, I don't feel good because I've given away all of my rights to this data. So when we were thinking about this project, how do we make more people comfortable? You make the data open. You say, when it goes from my sensor, it's then going to relay into an open data portal, so you know what we know. And that feels pretty good. Two, it's open source. How does it work? How does the code execute? It's out there. Now, 99.9% of folks won't understand the code, but you give people the option. Three is And I talked about this with the Chicago Open Data Portal. It's force multiplication. Now, if you have, 10 billion rows of particulate data from all of these sensors, and you look to me and you say, Brett Crunch, I don't know anything about that stuff. Like, I don't know subtleties of particulate data. I bet someone does, and I bet he or she can't sleep some nights, and they can work on our data problems. But you are getting this, like, there are lots of people who want to help, and it's a way of getting the data out the door. Now, what AOT is exciting because, so while it originates at Argonne U of C, it is in fact going worldwide. So these are all the cities. I was out in Taipei a bit ago talking to their national lab folks, and these are all folks who are looking to implement systems. And it's going to be a standard, it's going to be open source, and it's probably going to be at the front of fixed place sensing. Now, how do we bring this all together? We talked about the robust data, open data platform, ways to deal with the problems we have going. Now, as we think a little more toward the future, I like to talk about algorithmic regulation. So Tim O'Reilly is a friend of mine. He's written on the topic. He wrote a chapter in Beyond Transparency. And the idea being, how can you take all of these different data sources, how do you have real-time measurement, and how do you make decisions and change systems based on the data you have? In its simplest, dynamic tolls, dynamic rerouting, all of these different things. Now, when you think about it, I guess if you talked to me about a couple of years ago, I'd say it was fantastical. Now this is very real. The data exists. It becomes more of a political question or an implementation question. But it's a really interesting area where if we can educate policymakers and we can get people to understand the power of data and start to say, what are the outcomes we're driving to? You can start to leverage the principles of algorithmic regulation and start to change systems. We as whatever we want to be, government, researchers, residents, citizens, need to start thinking about how we raise the bar using data. We need to understand that these things can become real now, and we need to be a good support system and change agents to drive toward these foundational, smarter mechanisms. And then at the same time, you start to empower people with what I call what-if models. Now, it used to be, and I quit before, you'd do a study for 2 years and then you'd analyze it and it would be completely useless. We now live in a day, and I think there's a video in there, but who knows if it'll do anything. It's people walking. Where we have the computing problem, the computing power and the mathematics and the models to say, if I do a tiny little tweak to a system, I can start to anticipate the outcome. And the simplest ones, if we go back to our high resolution spatial data, if I reroute dude to go left instead of here, the overall system will be impacted. These are all solved problems now. We need to start to say, as government and as policymakers, what are the little changes that we can make? What are the anticipated outcomes? What are true decision support tools so that we can actually realize that vision of data-driven government and a smarter city, but in a way that's driven by computer science, data science, but grounded in policy. These things can be real. We need to move beyond the rhetoric, but they can be effectuated now. So there you go. I went a little over, but thank you.